You didn't learn how to do an area under the curve? That's a big no. You're all looking like, ah. All right. I'm going to teach you how to use a trapezoidal rule. Well, I'll just relax and listen. Okay. Don't write anything. Just relax and listen. You'll have plenty of time to write later. Okay. To use a trapezoidal rule to determine the area of the curve. Okay. So let's say this is our area of the curve at steady state. Okay. Between 0 and tau. So here's the end of our dosing interval. Here's our area of the curve. So this is our area of the curve at steady state. This is concentration, and this is time. Okay? Y'all with me? Everybody good? We want to know what the area under this curve is. Well, how the heck are we going to determine that? There's lots of ways to determine it. You can even use a cut and weigh measure. Get this. You can plot these on paper, cut them out, and then compare their weights of the paper as long as the paper is the same. We did that when I was in school. We called it cut and weigh method. You can also use different derivatives and stuff to figure this out. But what I want you to be able to do is use it, compare, or to be able to determine an area of the curve using the trapezoidal rule. Okay? What is the trapezoidal rule? Well, what does a trapezoid have to do with this? This is not a trapezoid. What we do is these are all concentrations that we know. Okay, here's a concentration we know. Let's just say it's 5. And at steady state, since we're going to give this again by definition, this is going to be 5 again, isn't it? And this is in milligrams per liter. Okay. And so at time 0 and at time tau, we have a concentration of 5 milligrams per liter. And let's say this concentration is 15. I'm just going to make numbers up. Okay. And let's say this number is 8. Now, the more data points we have, the better we're going to be able to predict or be able to measure our area of the curve. The fewer, the less accurate we're going to be. Okay. So let's just work with these numbers here. So what we're going to do is we're going to chop this curve up into pieces by dropping a perpendicular from each of the points that we have. Okay, so I've dropped a perpendicular between our 5 and 15 and our 8 and 5. And let's say this is at 2 hours, this is at 6 hours, and this is at 8 hours. I know this is not to scale, but just bear with me. So this is just to give you an overview of the idea. Now you might believe, what is a trapezoid? A trapezoid is where you have parallel lines for two of the opposite 2 lines of a 4-sided structure are parallel, and then the other 2 aren't, right? And so this does make a trapezoid, doesn't it? You got your 2 parallel lines and then the 2 that aren't. So what we're going to do is measure each of these trapezoids. Now, I don't know, when you took geometry, I was irritated by geometry for some reason because it didn't really feel like math to me, because I just like doing arithmetic, I think, at the end of the day, because it's satisfying. But geometry, you got to kind of understand shapes and how they, remember all those proofs and rules and everything. Well, it turns out this comes in handy. What we're going to do here to measure this trapezoid is we're going to use little geometry rules, because we're going to actually measure a rectangle. We can easily measure a rectangle. It's just height by width, or width by height, right? Yeah, height by width. But this is not a rectangle. Well, what we're going to do is we're going to say the midpoint between these 2 points. So 15 plus 5 is 20. So what's the midpoint? 10, right? So at 10, we're going to find the midpoint here, and that's 10. We're going to draw a line here, and this is the rectangle that we're going to actually use the measure. So we're going to have 10, the height is 10, and the width is 2. So the area of this rectangle is 20. And if this is hours, we're going to have 20 milligrams per liter times hours, aren't we? That's the area of that rectangle. There's Olivia. A little slow getting going this morning. That's all right. Love you. I'm glad you're here. I'm glad you're safe. Okay, so, but you'll say to me, well, Dr. Earl, why would this be included as part of your area and you're not including this piece? Why? Because there's a rule with geometry that if these angles are the same and these are parallel, that these two have equal areas. So we're switching one out for the other. Isn't that cute? You love geometry too? Me either. But turns out comes in handy. So this area is 20 milligrams per liter. Liter per hour, milligrams per liter times hours. How do I get my units? This is height times width. So what's height times width? Height is milligrams per liter, width is hours. So just make your units match your height times width, right? You all knew that though, right? All right, so what's going to be the area of our next trapezoid here? Well, let's see, what's 15, 8. So this is 13, carry the 1, 23 divided by 2 is 11.5. Did I do that right? So this is going to be 11.5 times what? What's our width? Right, times 4. So 11.5 times 4. So this is 46, isn't it? Again, we're trading these two triangles. And how about this one? 8 plus 5. Again, it's 13 divided by 2, which is what? 6.5. Did I do that right? So 6.5 times what? 2, right? So 6.5 times 2 is 13. So what's our area of the curve? 20 plus 46 plus 13, 9, 679 milligrams per liter times hours. It's not hard, is it? A little tedious. Can you all do that? No? Yes, you can. Yes, you can. So that's how well, I'm going to do another I'm going to do one with you that you can practice. Okay. So we've got, here's how that's how you do a trapezoidal rule. And that's easy when you have all the different rectangles there. What if you want to go 0 to infinity? Or as I like to call it, the Buzz Lightyear area of the curve. How many Buzz Lightyear fans? No? Hi, Lane. Do you like Buzz Lightyear, Lane? Oh, he's ignoring me. He escaped. Do you guys not know Buzz Lightyear?
We're just Team Mr. Potato Head over here.
Oh. Now, I know Buzz had a new movie, which I did not see, but from the early days of... Anyway, infinity and beyond. So what happens? Well, you've got this tail on here that takes you out to infinity, right? So how do we figure this is actually a triangle too, isn't it? How do we figure that out? I don't expect you to know that. You take your last concentration and divide it by K, and that gives you the tail. So you add whatever your last concentration was, divide it by K, and that gives you this area. You have to add that on then to your 79. All right. Why don't we take a 5-minute break and we'll come back and practice this, and then we'll talk about bioequivalence or bioavailability. Sorry, I was eavesdropping. You guys are funny.
How's it going? You like it? A little bit of math. Yeah, so.
Hey.
Yeah, that's.
It's fishy. It's fishy. Yeah. But like. She just likes yeah, but she just wants to as the expert to find each one. To find that. No, it did. It's fine. If someone stood up and said it out. This is not a banger. How was your birthday, bro? What did happen? Just walking around with your phone. What did you do? Yeah. Oh, that's good. Like they were like on each other. Damn. I need to lay down. Oh, my girlfriend's here. My leg, bro. I like my legs, buddy. I like my. I was ready to have my feet. Got my feet. Oh, I'm saying I always
I'm like, get my card. I'm like, yeah, I'll get you. I'm like, I'm gonna hand you my card. I had trust level. That's not it. It's ridiculous. I think ice. You saw me too. So I had to like lock it. I was like, let's go back and meet you right now. More in Devon this year. Women's restaurant is like 20 minutes, dude. Dude, God is telling you. With some friends, you're gonna be there for hours. Oh, I always love it. That's not you. I just.
Still get in there.
Thursday. It used to be fun.
I think.
No class stuff. You guys start. This weekend. I'll try to. I mean, I can find that Friday, but I can't be Saturday.
Oh my God.
After that, yeah, it was fun. Last time did you drink vodka? I want to get T1.
Oh, yeah. Well, I'm gonna do it. It's like your dad.
He just lost.
How would you get it here? Dale skis.
Is it your birthday today?
No.
Oh, shoot. Everybody's birthday?
Thank you.
All right, I got my coffee. Hopefully things will look up. All right. You guys ready to do an area of the curve? Now this you have in your should be in your module in your on your Canvas page. So here's new drug Jeepers. And notice it has an area to the curve 125. This is 0 to infinity. So we got the Buzz Lightyear, so we have to think about the tail. When given a 500 milligram dose IV. So we know it's 125 milligrams per liter per hour for the area of the curve 0 to infinity. When given IV, please determine the bioavailability of Jeepers if it's an oral 500 milligram dose, so the same dose, so we don't have to worry about changing the area or fixing the area of the curve, or I'm sorry, the bioavailability for different doses. It's the same dose. If the following time concentration data is determined. So we need to figure out the area of the curve 0 to infinity for oral jeepers. So we've got this data. So if we, and what I would do is just go right on your whiteboards or whatever, and I draw this out. You will learn I'm a very visual person. So I would draw this out. So at 12 hours, we're at 1.25. We need to figure out to infinity though, don't we? At 6 hours, we're at, I'm sorry, 6 hours, we're at 4. This is not to scale. Wait, 6 hours, we're at 5. At 4 hours, we're at 8. God bless you. And at 1 hour, I didn't draw this right. So we want to look like this. Okay, how do I erase? Erase, please. Where's my erasing? This is milligrams per liter, and this is in hours, okay? Can you read my messy writing? So I think this is the actual curve. So if we know this is at 1 hour, 4 hours, 6 hours, 12 hours. Okay. So drop the perpendiculars like you did. First thing you do is drop the perpendiculars. Then we have to do all of our little, what are the numbers? 15, 8, 5. 15, 8, 5, 1.25. Okay. So let's figure out each of these trapezoids. So we have 1 trapezoid, 2 trapezoids, 3 trapezoids, 4 trapezoids. Yes. So what people usually forget is how to get the height. So we know the width is going to be 1 hour here, right? But how do we get the height? It's just the average of these 2 points. So the midpoint of those 2 points. So it's going to be 7.5, right? I don't know where 7.5 is, but let's make that 7.5. So 7.5 times 1. So this trapezoid is 7.5 milligrams per liter time hours. Everybody good with that? Now we have to find the midpoint between 15 and 8. So 8, 13, 23. So that's 11.5. Is that right? Yes, did I do that right? 11.5. So the height of this one is 11.5. So 11.5 times, what's this? 3, right? 11.5 times 3. Is everybody with me? $34.5. And what's the midpoint between 8 and 5? So that's 13, 7.5, yeah? And what's the difference in time? 2, so this is gonna be 15. And now, huh? 8 and 5. Yeah, 6.5, sorry. 6.5. So this is 13. Thank you, Harbin. And then 5 and 1.25. It's gonna be 6.25 divided by 2 is 3.125. Yes, 3.125 times 6, right? This is gonna be 18.75. So we have to add up all these rectangles. That's not right. Doing something funny with my, it's really important to know where you're going so that you can try to catch yourself. Did you get 73.75? So 0 to the end of the dosing interval is 73.75. Now, how do we get this tail? Because we have to go to infinity, don't we? Remember, it's C last divided by K. C last means your final concentration, which in this case is 1.25 divided by K. Do we have K? Can we determine K? Sure we can. So what I would do is look at 15 to 1.25. So your natural log of your C2, which is 1.25, minus the natural log of your C1, which is 15, divided by what? What is that? 11 hours. Y'all know how to do that to get your K. It's just rise over run, isn't it? Everybody good with that? No? Yes? I usually try to pick as far apart as possible just because I get a better, but you should be close with any of them. What'd you get for your K? Yeah, that's what I got too. And this is a negative slope, right? It should come out to be a negative number. Does that mean your K is negative or that your slope is negative? Your slope is negative because you can see this is if you think about in that first quadrant, in order for it to be a positive slope, it's going to be increasing, right? And obviously this is decreasing with time. So it's always going to be a negative slope, but your elimination rate constant is not negative. It's always going to be an absolute value. So your K is 0.226. I don't know what's wrong with me today. 1.25. 226. Did you get 5.53? Did I do something wrong? I don't know what's going on with me today, but 1.25 divided by 0.226. What'd you guys get? Oh, okay, so I'm right. All right. So this tail, God bless you, is 5.53. So we add that then to 73.75, and we get an area of the curve of 0 to infinity for the PO, 79.28 milligrams per liter times hours. Yes? Were you all able to get that? Yes, yes, yes. And our area of the curve IV was 125. So we are going to, our bioavailability is going to be our area of the curve PO over our area of the curve IV, as long as the dose is the same, which it is. Otherwise, we'd have to accommodate for the dose. So we're going to have 79.28 divided by 125, right? So about 63%. Yeah, is that what you got? Everybody good? So I think I went through this all in detail here. All right, so you can follow through this if you need a reminder. I am gonna give you one of these on your quiz. Won't have this many trapezoids. It'll probably have 3 trapezoids. Yeah. All right, everybody good? You ready to talk about bioavailability now? All right, so we've talked about how to measure different bioavailabilities and compare them, or measure area of the curves to determine bioavailability. And that's from data. But what actually determines the bioavailability in a patient? What determines bioavailability? All right. Everybody good? All right. Has anybody done or helped me on VIP 2 squared day when we do the American Ninja Warrior? Yeah. So that was all about bioavailability, if you remember, and that's what we're going to be talking about today, is how at VIP 2 day, we try to do things that are fun, that are about, pharmacy stuff. And I was thinking about how bioavailability and the trek of a drug from when you take a drug to get to the systemic circulation, it's like going through the challenges of an American Ninja Warrior. You have to be able to do this and be able to do that, be able to make it through all these different barriers in order to make it to the systemic circulation, which is your goal. All right. So we're going to talk about this sojourn or this journey of a drug through the body. And y'all know Miss Frizzle. Are y'all Magic School Bus? Well, think about us. We're going to now take a little travel